This is a presentation of a new 3D viewer, based on the technology of WebGL Publisher, which is a framework for handling 3D models in web browsers. Beside the pure 3D viewing, I will show you implementations of assembly structure views, annotation handling, model comparison, animations, virtual and augmented reality features. In addition to that, also 2D viewing is supported, including the definition of 2D annotations. WebGL Publisher models are based on a known format with the extension WPM, which stands for WebGL Publisher Model. It is a CAD-oriented format and supports assembly and layer structures, 3D meshes, points, lines, arcs, hatches, texts, labels, dimensions and animations. The format can be converted, for example, from common CAD formats like 3D XML, JT, and STEP. The converter can be downloaded from the WebGL Publisher website. 3D viewing is just one application using 3D models. The underlying approach is to use 3D models as an information base for software like ERP, asset or spare part management, or as the base for a digital twin. Let's start with the viewing features. To demonstrate the 3D features, I am going to open a 3D model which was converted from Inventor using the JT export. The model shows a multi-level motor assembly and can be viewed by different angles using the mouse. The model can be rotated by pressing the left mouse button, it can be moved by pressing the middle mouse button, and can be zoomed rotating the mouse wheel. When the mouse hovers over a component, a tooltip with the component name is shown. The left mouse button behavior can be oversteered by clicking the icon bar buttons, for example to switch to the selection mode, the rotation mode, to movement, zooming, or to measurement. When a component is clicked by the left mouse button, the component properties are queried from the server and are displayed in a dialog box. The model can be displayed in an explosion view, where the components are moved away from the model center. In the measurement mode, two positions are queried which are clicked with the left mouse button. Afterwards, the position coordinates and the distance values are shown in a dialog. The measurement runs in a loop and can be stopped by pressing the cancel button. When an assembly is loaded, the assembly structure can be displayed in a model browser. The browser supports multi-level assemblies and displays the information in 5 columns. The buttons for showing or hiding assembly levels, the position number, the component name, a checkbox for hiding or showing components and a checkbox for highlighting components. In the default state, the model is sorted using the position numbers. This can be changed by pressing the button for an alphanumeric sort. Within a level, all multiple assembled components with the same name can be collected using the Collect Same Name button. Disabling the Show or Hide checkboxes hides or shows the corresponding components in the graphic area. Enabling the Select checkboxes highlights the components. The selection can also be operated by enabling the selection mode and by selecting the components in the graphic area. In this case, the subassembly in the model browser is expanded so that the selected component becomes visible. Each subassembly level can be expanded and collected using the plus and minus symbols in the structure view. In addition to that, all nodes can be expanded and collected using the corresponding buttons. When a component is switched to invisible, it can be suppressed in the structure view by enabling the filter icon. The viewer supports the creation of annotations. These annotations are stored parallel to the model so the model is not changed. Annotations which are added to the model are loaded from the hosting system after the model is loaded into the browser. Annotations are collected in groups and are displayed in an annotation list. As a default, the groups are named with their creation date so you can build something like a chat on a 3D model. Currently there are 4 different annotations available. A sphere area to mark regions in 3D. An information point which references on external websites or can trigger an action. A text label. An image label. First, the center point of the sphere is queried. Afterwards, a radius point is queried. The group name is filled with the current date. A tooltip and a color for the area can be defined. When the mouse is placed over the annotation, the tooltip is displayed. The annotation is added to the annotation list and can be highlighted or turned off. First, the position of the information point is queried. A tooltip and a color for the area can be defined. When the information point is clicked, the referenced web page is opened. For the text annotation, 2 points are queried: the position of the arrow and the position of the text. Beside the 2 positions, an image annotation needs an image to be displayed. The image can be selected from the local file system or from a photo created with a mobile phone camera. The width of the image is defaulted with 10% of the model size and can be adapted. When 2 models share the same components, there often is a need to compare these models and display the structural differences. The viewer provides features which support model comparison. After the compare model is loaded, an additional structure browser for the compare model is shown, which can be steered in the same way the primary model browser is steered. By clicking on the browser toolbar, the corresponding model is activated. The 2 browsers can be organized side by side on the left or on the right, or can be distributed. To show the differences in the graphic area, the compare mode can be activated by clicking on this icon. In this mode, both models are displayed. The primary model is displayed in a semi-transparent color, the compare model in full color. There is a possibility to highlight shared components in both models. These components are shown in both browsers and in the graphic area. Or to select components which are unique in each model. The position of the both models can be changed by mating a shared component. The mating moves the 2 selected components so that they overlap. This gives a different impression of the geometric differences. The performance of the viewer is good enough to handle also large assemblies. This is an example of an extrusion line, which was converted from the JT format. It shows an asset for manufacturing foils. The assembly has over 4,000 components. Animations are important features when you want to provide model simulations. The viewer supports animations which either are stored in the model or are created outside by the web page. This is a model of an injection mold with stored animations. When animations are present, an additional icon is shown in the toolbar. Clicking this icon brings up a dialog, where the animations can be handled. Animations can be started, stopped, and can run in a loop. This is an animation which combines translation and rotation. This is an animation which positions components to specific points. When an animation is looped, the user can still interact with the model. Multiple animations can run parallel as shown in this example. In augmented reality, the person's perception of the real world is enriched with computer-generated content like 3D models. For presenting the augmented reality features, a mobile phone is used. The mobile phone shows the same model as previously presented at the computer screen. The camera input is taken as a background and the model is added to this environment. When the model is pinned to the environment, the mobile device angles are used to compute the position of the model, so that the model is displayed at the same position. In virtual reality, the viewer is positioned inside of a 3D model. For presenting the virtual reality features, an architecture model is used, which was exported from Autodesk Revit. In virtual reality mode, the environment is presented as a 3D background image, which adapts to the viewing direction. The user can walk through the model and turn around or change his position horizontally or vertically. To handle viewer positions, a new menu is displayed. To store the current location, select Save Current Viewer Location, and give the location a name. The locations are marked with an icon in the 3D model, which can be selected. The locations can be stored parallel to the model in the same way as the annotations, and are added automatically after the model is loaded. In this sample, 2 additional locations have been loaded. Selecting the menu Handle Viewer Locations brings up a dialog, where the locations can be used to position the viewer to this location. There is a possibility to copy the model content to a new image, which can be viewed in a new website. The virtual reality mode can also be used with mobile devices with additional functionality. Using a mobile phone, the device angles are tracked and are used for calculating the view. So turning the mobile phone emulates a head movement of the viewer. As demonstrated in the desktop computer environment, it is possible to move inside the model and to click on the location icons to get positioned at saved locations. There is a possibility to include the camera video stream into the virtual reality, and to mix the virtual and real reality into one environment. The mobile phone can also be used as a virtual reality device by placing the mobile phone into a headset. To steer the movement, an additional pointing device is needed. In this example, a mouse is used for this. Since the view is rendered for each eye individually, the display has to be switched to stereo view by clicking on this icon. To enlarge the display, the toolbar can be minimized. The pointing device is used to move inside the model. In addition to 3D models, also 2D images and PDF documents can be viewed and can be enriched with annotations. This is an image of a mechanical drawing. Just like for 3D models, annotations can be added to the image and can be stored parallel. The following annotations are supported. Information points referencing on websites as for the 3D model. Colored areas like circles, plates and rectangles. Text and image labels as demonstrated for the 3D model. There is also a possibility to measure, but since this is an image and no geometry is present to measure, the measurement has to be calibrated. The calibration takes two positions and queries the distance value between them. After the calibration, 2 points on the screen can be used for measuring. The viewer supports also multi-page formats like TIFF or PDF. The user can scroll between the pages with the toolbar icons. When annotations are added, the annotations are fixed to the current page. So when a different page is displayed, the annotations are refreshed. What are the benefits of the solution? It is completely browser-based and therefore runs locally or in cloud environments. It works on many different devices like mobile phones, tablets, PC or Mac computers. There is no special hardware needed, like specific virtual reality devices. Since a mobile phone is normally available, it is ready to use in everyday situations. It can be integrated in every web-based software with JavaScript or in desktop software using browser controls. There are no dependencies to third-party programming libraries. And there is no dependency to software infrastructure like Facebook or Steam.